Hi, I'm Metta Spencer. Today we're going to go to Hudson Bay again, which is, I've never been there really, but it's one of my favorite places nowadays because I spend a lot of time thinking about how we can cool the place. My concern is that the Arctic is warming about 4 times as fast as the rest of the world, and it's melting a lot of releasing CO2 and methane. And that just scares me more than almost anything else happening. So I'm trying to figure out ways of cooling the Arctic Ocean and even the permafrost in the Arctic. And one place that we might start was with Hudson Bay, because I live in Canada and Canada owns Hudson Bay. So we don't have to ask permission from anybody else if we experiment with things. So I've been talking to a lot of people about things that we could do to cool the Arctic, and specifically starting with experimenting with Hudson Bay. So I have 3 people here who know a lot more about it than I do. And we're going to have a conversation about the various alternative ways in which we might be able to chill the place down a bit, and maybe even refreeze the Arctic oceans and keep Hudson Bay frozen throughout the summers. So in Edinburgh, Scotland, I think you are, that's where he lives, is Stephen Salter, who is an emeritus professor of engineering design at the University of Edinburgh. And he's somebody who spends a lot of time figuring out how to make nozzles on squirt guns. Not quite, but he's invented ways of making very fine systems of spray that will, he can spray into clouds, which will make the clouds a little lighter particles, and lighter particles are white, and white clouds reflect the light back into space and cool the place underneath. So that's our favorite potential way of chilling the Hudson Bay. Now, also, not also, but in Ottawa is my favorite climatologist, Paul Beckwith, who is a physicist, an engineer, and a climatologist, and he teaches off and on at the University of Ottawa, but mostly he makes a lot of videos, and I spent a good part of my night watching some videos that he made recently at the COP meeting in Egypt. And here in Toronto, but we're just getting acquainted, is Megan Sharamata, who is an environmental scientist at the University of Toronto. She's a PhD candidate, and she specializes in environmental change in the East Hudson Bay region. And she actually goes and hangs out with people and knows what life is like for people living in the coastal regions of the Hudson Bay. And also here with me in Toronto is Adele Buckley, a very dear friend and a very active member of the Canadian Pugwash Group. And she is a physicist and engineer, and somebody who shows up very frequently to question the people that we're interrogating about means of working, intervening to stop climate change or reverse it. So I'm always glad to have Adele present to ask pertinent questions. So I don't know how to start here, because my notion was I wanted to have today, if possible, to think about alternative means of cooling Hudson Bay, besides the one that we've been investigating most, which is to brighten the clouds. But some of the people that I wanted to ask about this, I haven't been able to reach and get them on board. So we'll have to speculate about the alternative methods of cooling Hudson Bay. And that will, I think we have some people who can do a good job of speculating. And also the beauty of having Megan here is that she can fill us in on what the people are experiencing living on the shores, people who make their living by often going out on the ice. And, so she is able to tell us what the social situation is that is being experienced by people who are undergoing the worst effects of climate change. So I'll get to you in a bit, though. Stephen, let me start with let's give a real quick recap of what our original notion was, that we're going to specialize in talking about how we can cool Hudson Bay, possibly even refreeze the ice in the summer or keep it frozen, and by brightening the clouds. And you're the man who's been working on that for many, many years. You want to give us a 20-second summary of what your notion is that we could do within a few years if we got busy right now on it?
Okay, it'll take a bit more than 20 seconds. The physics began with some work by a chap called Sean Toomey, and he was able to fly over clouds and measure how much energy was coming from above, how much is being reflected back up, and how big he could fly into them, and he could measure the sizes and the numbers of the drops in them. And he did a lot of work which has been pretty well accepted now, and it's been replicated, and everybody believes it. And it boils down to the fact that if you have a lot of small drops in a cloud, you get a high reflection. And if you have the same amount of liquid water in a smaller number of bigger drops, then it's a darker cloud. And you know that because you've heard people say the dark storm clouds are gathering. And you can test this idea with little glass balls of different sizes. And I can show you some of those. And what we have to do is to increase the number of drops in the cloud for the same amount of water. And you need to understand that to make a cloud drop, you can't just have the relative humidity going up to 100%. You also need a little seed, they call it a condensation nucleus, to get the drop started. And once it's grown over a certain size, then it can keep on growing. And this depends on some work by a chap called Kohler. And we know the sizes of the drops you need for different kinds of relative humidity and different kinds of chemicals. And the really important thing to realize is that the amount of energy you need to make a condensation drop from seawater that's going to be the right size is very, very much smaller than the amount of energy that will be reflected by the cloud drop that grows on that seed. And it's many millions of times. So we have a way of spending a very small amount of energy in an intelligent way that will make us able to reflect a much larger amount of energy. I mean, it's 10 to something, I can't remember it, but it's so big that it really is a wonderful tool. And the way to do this is to filter seawater and then squirt out tiny drops below a micron in size, and they are mixed up into the bottom of the atmosphere because it's turbulent. There's a boundary layer which is a bit like stirring cream into your coffee, and that gets the little drops creating bigger cloud drops. And the cost of it seems to be really very, very affordable, maybe even cheaper than having COP conferences. So that's marine cloud brightening, and the names are Sean Toomey and John Latham, who thought of the idea of applying Toomey's work. I'm just trying to do the engineering.
That's wonderful. Okay, and I'm delighted to say that we have somebody who's joined us since I introduced everybody else. It's Lawrence Martin. Lawrence is a Canadian musician and politician of Cree heritage, and he has been previously the Grand Chief of the Mushkegowuk Council. Is that how to pronounce it, Lawrence?
Very close. Mushkegowuk.
Mushkegowuk. Okay.
There you go.
That's good. But now you're doing, you're the chair of a marine conservation area that is administered by, is it the Mushkegowuk people council? Is that right? I haven't quite got your title down, but I know that you're actually doing hands-on administration of trying to save the environment. Is that right?
Yeah, that is correct. The title that I have is the manager of the National Marine Conservation Area feasibility study of James Bay and Hudson Bay. So we're doing that now as we speak, and we're now going into our second year, getting everything all organized, and certainly taking a look at all the various studies that have taken place in the past, including some of that kelp we talked about the last time. And now we're finding out a lot more. We just saw a film by National Geographic, people that were in Hudson Bay this summer, of what they were able to find at the bottom of Hudson Bay in various places that they dove into. So that's going to be released this coming year, and we're looking forward to that. And so we're going to continue with the studies, and certainly what we're talking about here is of great interest. So I think certainly my staff, my colleagues here at Mushkegowuk Council, I told them about our last conversation we had, and they were quite interested to learn about, the mist that the gentleman was just talking about now that can be created over the Hudson Bay, or any ideas of how to be able to prolong our lives here on Earth as human beings, I suppose you can say.
Well, I'm glad to hear more about that, because I know that it's not like we're going to bound ahead doing things on our own when you are the folks living there, you're the people who have to live with what the consequences would be. Have you met Megan Sharamata by any chance? Megan, do you know Lawrence?
Oh, Jay, Lawrence,
Hi.
We've never met, but it's great to meet you.
Oh, you too, likewise.
Yeah, Megan is an environmental scientist at University of Toronto who spends most of her time on the east, with the people on the east shore of Hudson Bay.
Okay.
Hudson Bay is such an enormous body of water that the people who live on the east shore are, 1,000 miles away practically from the people on the other shore. So you may not even know each other that way. Okay, I want to bring both of you in, and mostly here's this. We don't know what can be done to chill the water, but it's just so important to chill the entire Arctic, and there are things that we know could work. The question is, would they have side effects that we wouldn't like? And not only that, but would people want it to happen? Suppose we could refreeze the Hudson Bay so that it's frozen, at least partly frozen in the summers. Would this be of value, and would people want it to happen? And what would be the social impact of doing that again? I want Lawrence and Megan to tell us, because maybe I don't know, we can do it anyway, but
before that, why don't we get Megan and Lawrence to tell us what's happening with the ice on a yearly basis in Hudson's Bay right now, where they are, and how that's different from, say, 10 or 20 years ago. Like, where are we at right now?
Good point. Okay, who wants to go first? Megan, let's have you, because you were here first.
Well, I was going to say maybe Lawrence should go first, since it is his homeland, and
okay.
he probably has a lot more information to share than I do.
Okay.
Well, I don't have much scientific information, but I've been working with the elders a lot since we started this project, and me growing up in this area also, I've heard stories over time about what the changes that are going on in this area. So, and particularly to the ice in the Hudson Bay, I know this summer, for instance, I mentioned National Geographic people. They were out there in their ship, the 64-foot ship, and they were having a hard time getting around because of the ice ice is moving around chill out there. Now it's in July, near the end of July. So there's still a lot of ice, but at the same time, what we see as people on the shoreline is that there's probably less ice because now we have a lot of polar bears that are moving inland into the shores, into the bush, like even 150 miles inland from the shoreline, and they're going after beavers, for food and that sort of thing. So we know there's changes happening because of the animals and how they're moving. We also see a lot more polar bears moving into the James Bay area, into the Agamaskie Island area. So our counts are actually increasing on the number of polar bears that are entering James Bay. So we feel, and what the elders have been saying, is because of the lack of ice for them to be able to continue their hunting out in the Hudson Bay, why that's going on. So obviously there's the climate change, the warming of the earth that's going on, and it's affecting the animals, and therefore they're moving. So that's how we read what's going on the ice in the Hudson Bay. And in the James Bay, ice is the same thing. We had another ship that was out there called William Kennedy this year, and again, same thing. They were having trouble getting around because of ice that was now floating around. And smaller chunks, mind you, but still floating in the currents that are being blown in from the north, from the Hudson Bay area. So there's activity there. And when we fly along the coastline, we see the animals that are out there, seals and so forth, out sunbathing early March. Now it's getting to be sometimes the odd February once they're out there. So there's a change of ice that's going on altogether. And
I'm sorry, I'm lost on that. Excuse me. You see, these are seals or something that normally would be when, and you're seeing them
later in the springtime, later in the spring, like in April, they would be out sunbathing. We call it sunbathing on the ice.
I see.
But now they're coming out earlier.
So that means it's warmer, and
it's a lot warmer. Yes, for sure.
Are they as healthy, or do you know whether it's affecting them? Which would they rather have?
Well, well, I know from the polar bears. I mean, the polar bears depend on the seals for food, and so when there's a lot of polar bears coming inshore onto the shorelines, that means they're not able to access the seals as much because there's no ice for them to be able to do their hunting on that. So there's an impact. There's a impact that's going on. So maybe it's the thawing of the ice that's affecting the polar bear from getting onto the ice, and therefore the seals are now much more in abundance because there's less polar bears being able to hunt them out there. So we see that correlation of activity going on. And also in the southern part of James Bay, we see now polar bears coming right into the communities at Moose Factory, which is way south. So that's a new phenomenon that's going on. So obviously there's lots of changes happening, and people keep telling us that yes, it is, that there's the permafrost that's also melting on the river systems. So that's affecting how the rivers flow in the summer and especially in the springtime. So we see that going on. And how does it correlate with the scientific findings? We haven't really tested those out specifically to try and match the science studies versus what our elders are telling us. I'm just telling you what I've heard the elders say.
But in general, if possible, you would like to have it colder.
Well, I guess that's something that would have to be talked about in general. We're going to be going into the communities starting in March, and having these 3-day events in every community. So we'll be talking about a lot of these scientific studies that have been taking place, and also asking the elders and the community members themselves about these types of questions. What can be done about the climate change? They don't really say what can be done. They only see, and what they see going on is what they share and what is about to happen. Not so much of what can happen by trying to make any changes by the human race.
Mm-hmm. Okay.
A few decades ago, was there lots of open water in the area you're at in summers by the end of the summer?
Yeah, definitely. When we're flying out over James Bay, you can see that some ice was out there, and but the further north you go, there's more ice that can be seen. And right now, even in the summertime, when we go out, say in August, you see a lot of ice that are now being blown into the shore. So there's ice at the ice. It's not as solid, it seems. It's breaking up and it's being able to be blown into the shorelines a lot more, which makes it harder for the people that are out hunting to get out, to try and squeeze out of the estuaries that they live near.
But tell us how this is affecting the people, how they did things, I don't know, 30 years ago and how they do it now.
Mhm.
A lot of the hunters, when they were out there, they witnessed those changes, and therefore it affects how they hunt and where they actually would go. Mind you, in areas to the south, there's more access because there's less ice. So they're having a different impact on the hunters and access to more food, more geese, more of everything that they get. But to the northern folks, it seems to be the other way around, because of the ice, the way it's moving around, it's blocking certain passageways that they normally would be using. So that has an impact on what they're able to use for food. So it depends where you are exactly, and how the weather patterns change over from the Hudson Bay to the James Bay. It's quite a distance, and there's quite a bit of difference.
Now, are you sort of a master of the whole Hudson Bay area, or do you? I think you're mostly you mostly concentrate on things on the east and south east shore, right? The wetlands and so on.
No, we're
Is
on the
that
west
right?
side. We're on the
Uh-huh.
west side.
Uh-huh. Well, Megan is specializes in the east side, so
That's right.
let's have a comparison of notes there. Megan, I read some things, and even I've quoted some things that you wrote about how it's affecting hunting and so on of the people that you've stayed with. Tell us about the life on the east shore of Hudson Bay.
Well, like Lawrence has just said, I can only tell you what elders and younger hunters from the Belcher Islands, which are off the coast of eastern Hudson Bay, the community of Sanikiluwak, and the community of Kujarapik and Umuyak and Inukjuak. So they're all the communities in that really semicircular curve that we all kind of recognize from our high school maps, all along the coast there. And they asked me to work with them to document changes that they've seen in the sea ice environment. So the ice itself, the surface waters, and wildlife. And going back to the 1970s. And so these are Inuit communities, and Inuit are sea ice users, and have historically used ice going quite far down the it's like eastern James Bay, so along the coast of Iuishi, which are the homelands of Cree, on the other side from Mushkegowuk territory. So I haven't worked that far south, but sharing some of the results of our work, which Inuit and Cree have started to do within their own knowledge sharing conference within the Hudson Bay Consortium over the last few years, has really allowed people to exchange ideas about their concerns about all these changes and about sea ice loss and about their priorities. And, when we talk about like big decisions like that, the first thing that is always coming to my mind is Indigenous self-determination, that we're talking about their homelands, even though it's, as you said at the beginning, it's all within Canada. These are Inuit and Cree homelands, first and foremost. So whatever happens there, really, they should be the decision makers of what happens on their lands. And anyway, so just going back to the 1970s, the reason why 1970s was of interest was because that was when the James Bay Project was initiated. Construction was complete by the early 1980s. And that's when environmental change really began for Inuit and, of course, the Cree, who were affected by the flooding of the building of the infrastructure of those dams. But important to note, and I'm someone who grew up in Montreal, and I grew up on James Bay electricity, essentially. We heat our homes with electricity, and so we use most of our electricity in the winter months. And what the James Bay Project did was it flipped what, freshening of the marine waters used to happen in spring with snow and ice melt. And spring extends all the way to June, maybe even early July in eastern Hudson Bay. And now we see peak freshening in December, January, and February. And for those of you who are climatologists, any sea ice climatologists know that this really affects ice atmosphere interactions and really drove sea ice loss from the results of our work together until the mid-90s. And there was effectively the loss of what was once a very thick, stable sea ice platform, as thick and as productive in terms of providing for wildlife habitat for hunters as ice very far up in Nunavut. And that the loss of safe, navigable sea ice was immediately perceived. And so there's been a lot of team-based work, really led by Inuit and Cree. Now they're looking at sea ice changes more closer inland. I don't know if Lawrence agrees with this, but the elders that I spoke with always referred to Cree further south as people who lived in the trees, who didn't use the sea ice as much. So, and Inuit used to go down to Agamaskie. Actually, I think Agamaskie is technically in Nunavut, although when I was in Mushkegowuk territory doing some work a few years ago, Cree, it's an island that Cree and Inuit have used since time immemorial, as far as I know. Maybe Lawrence could tell me something about that.
I should put in a map. Maybe I can find one later and superimpose it over somebody's face here, but I can't visualize it in my head. But maybe we can find a map later, because you're talking about something that we should be looking at. Okay, thank you.
I've been looking at my map behind me the whole
Oh yeah.
Hudson Bay, James Bay. So
Lawrence, I don't know if you can answer this, but many elders who've passed in the last few years, there were a couple from Chisasibi who lived in Chisasibi who used to do a lot of sea ice hunting in James Bay. And there were a lot of Inuit maybe living in what now are called Cree communities, but there are a lot of Inuit and Cree on the land in northern James Bay, and that the loss of sea ice has in the 80s had a big effect on Inuit ability to go down into James Bay.
Yeah, a lot of our stories of the Inuit stems back maybe say 150 years ago, when there was a lot more interaction going on amongst people of all the Hudson Bay, James Bay areas. And so the Inuit have not been in our area since then. I know Agamaskie Island that you talk about, it's again, the stories are the same. The Inuit haven't been there for a long time, and there's a lot of different changes that have happened too. That we used to have a lot of walruses on Agamaskie Island. They no longer exist there. They now have moved further up into the Hudson Bay, where Hudson Bay, James Bay meet on Cape Henrietta, we call it, on the west side. So that's where the walruses are stationed today. So that's a big change. And we even have names of places referring to the walruses further into the James Bay, down into James Bay, but they no longer live in that area. So those are some of the changes that have happened. And yeah, none of it is, I guess, has Agamaskie Islands and all of the islands in James Bay as far as when they were created by Canada. So that automatically came with that possession that they could have. But as part of our discussions here we're having with Nunavut on the islands like Agamaskie, there's a willingness to, talk about that and to refer it back to us, to the Mushkegowuk people, for them to manage it. Because there's a lot of bird sanctuaries there. This is a flyway for all the migratory birds from the south, from Central America, South America, and so forth, shoreline birds, geese, you name it. So this is where they come. So we're obviously really wanting to work together with all people, not just in James Bay, but to the south of us as well, because that's where the birds come from, like from Mississippi and from, Florida area, everywhere. So we need to work together with them to make sure those birds are going to continue flying, be safe, and have food to eat. So we're mindful of that, and definitely mindful of how can we work together with the Inuit even more now. How much more can we protect all of Hudson Bay in this conservation effort that we're putting together? Not just James Bay, because with James Bay, it's easier because it's just basically two groups of people, the Crees on the east side and the Crees on the west side. But to the north, the bay is bigger, and we need to work together with the Inuit and with the people in the Manitoba area, Northwest Territories. So there's a desire to do that. It's just a question of time and how to do it. So I think
do you think that there's any incongruity between or differences of the interests? So far as you know, do any of these people have, are they advantaged by something that would be a disadvantage for one of the other groups? Are their interests aligned, or are there some incompatibilities of interest so far as you know?
No, everybody is, understanding of the environment and how we're all part of that life cycle. The humans and the animals and the birds and everything that we depend on, the food chain, we're all part of that. It's just a matter of where we live and how we get the food. So working together.
Now, for example, if it becomes possible and feasible to keep the parts of the Hudson Bay frozen throughout the summer, are there some people that who would find that a problem, that they wouldn't want that?
It's possible.
It's possible. Yeah.
We haven't asked that question, but if we put it that way, if people had a choice, maybe they'll have something to talk about. Right now, I don't think we have a choice to say yes or no, we would keep it frozen or not. We're just watching it melt away at this point and making plans and probably having to relocate our communities because of that and the impacts of that.
Yeah, well, we're thinking of fanciful ideas that may not be realistic, or there may be some side effects. Megan, if you know of any
well, I think what Met is getting at is, and can I just say a couple words on my thoughts? Indigenous self-determination, of course, is very important, but it's becoming so that none of humanity has any self-determination on the climate, right? I mean, we put so many fossil fuels, we burn so many, we've changed the atmosphere, the chemistry of the atmosphere and oceans we're suffering consequences of massive climate change. I mean, you're getting a lot more storms, I think, massive storms, and I call it weather whiplashing, where it goes from, say, for example, in Ottawa, a week ago it was -31 with a wind chill of -40 for several days, and now it's like 5 to 10 degrees Celsius. Okay, and it could swing back if another polar vortex came along. So the idea of weather whiplashing from one extreme to the other, I think that's very hard on all ecosystems. So I guess people in the north are seeing the warming much more acutely than people in the south. Meta at the beginning mentioned that the Arctic's warming 4 times faster. Well, for the longest time, scientists were saying twice as fast, and now then it became 3 times as fast, and Meta said 4 times. I mean, for years I've been saying it's 5 to 7 times faster. It depends on the latitude that you're at. The higher the latitude you're at, the faster the warming, and this is because the Arctic's becoming a much darker place. It's losing snow and ice. It's absorbing more sunlight. The Arctic amplification effect is ever increasing. So people, up until now, people really haven't been thinking much about, can we do anything to reverse this? Can humans do something? But now the problems are becoming so severe that it's really in the works that we may actually have to try to cool the Arctic, because a release of methane and CO2 and melting of the permafrost could shoot the Earth into a totally different regime, which will be taken out of human hand when the methane and CO2 are coming out of the Earth and they're dwarfing human emissions from fossil fuels. So it's a very nonlinear system and nonlinear process. So what the purpose of this meeting really is, we need to start giving people the idea that it may be possible for us to do things to reverse this huge warming in the Arctic. And so one of the ideas is that Canada could be the first place where this is done in the world, in the James Bay, Hudson's Bay region, because it's all within Canada. We don't have to deal with the international community getting buy-on from all of these different groups. So how would we cool this area? And there's a number of different ideas. Okay, Stephen Salter's work is on brightening the clouds, so that the brighter clouds, and these are low-level to mid-level clouds, basically, so that the clouds are brighter and they reflect away more sunlight, so it's cooler underneath the clouds. So basically cooling the regions, or the entire region of James Bay, Hudson's Bay, whether if it was done in the summer, I mean, the idea is to keep the ice around much longer. So if you thicken the ice and stop it from disappearing in the summer, you've got a bigger head start on ice regrowth in the winter. And if you manage to keep it around in the summer, then over time it can thicken because it never completely disappears. So that's what. So there's different ways we can look at doing that. One of them is marine cloud brightening, but Meta has concerns because it only works over open water. If you brighten the clouds over an ice surface, the ice is already highly reflective of the sunlight. So your bright clouds above the ice surface won't have as much impact on causing additional cooling. So you want to do that over open water, which is dark, right? Very dark. You're replacing, so the sun coming down, instead of hitting the dark ocean and being absorbed and heating the water, it hits the bright clouds above, reflects, and lets ice regrow over the dark water. Another idea is to go higher up. There's clouds behave differently on whether they cool and heat the Earth depending on their altitude. Okay, so low-level clouds generally are good for cooling the surface underneath the clouds. Okay, so that's the idea of the marine cloud brightening. But high-level clouds, I'm talking about the thin, wispy cirrus clouds, they keep the heat in. If you're in the desert and it's a cloudless sky, the swings of temperature can be enormous from day to night, because at night, all of the heat can radiate out to space. If you have high clouds, they reflect some of the radiated heat back to the surface, and they actually keep it warmer on the surface. So, we have a -30 day, it's going to be a cloudless night because the heat can radiate out to space. So one of the ideas to cool the whole region is to thin the high-level cirrus clouds. And if you reduce the number of high-level cirrus clouds, then more heat can radiate out to space and you can cool the whole region. Okay, so these are the two main ideas that we're thinking of. And the idea of doing it over Hudson's James Bay is that it can be a within Canada thing. We don't need international buy-in to do this. So that's the main thing. So I guess what Meta is trying to do is we're trying to get more information from people that live in the region, that see what happens year to year with the ice, and whether we would get buy-in to try techniques to cool the whole region and get back to thicker ice. Now, I assume there's less interaction between people living in the area now because they can't travel from one area to the other area across the ice like they used to, right? I think that's my, I could be wrong on.
I wouldn't assume that at all. There's a
Okay.
lot of long-term relationships, and we're talking about many different regions in this area. And I mean, I'm just, not to cut you off, but I do think that it is a multi-jurisdictional area where people have rights and who've experienced really negative effects from major development projects that transformed the environment in the pretty recent past in ways that had very negative impacts, not just on hunting, on people's ability to feed their children where they were feeding their, like there's a legacy of people from the outside. Can you just let me?
Yeah.
When I say
that,
starting from the Indigenous self-determination, like it really is important because there's a lot to learn from their experiences of environmental change that are relevant. And I'm not saying that people might not want to entertain this idea, but I do think that there's a lot of work to understand sea ice and salinity change. And there might be other ideas if you build relationships with this big network of Inuit and Cree and researchers who are supporting them to see what the reception would be. Like I would say, go there and ask people.
Yeah. My comment on self-determination is that none of humanity has self-determination. Under
land use decision making within Canada, like it's
I'm
just
saying
that's
under
the basis of our
change. The climate is, we've set the climate change in motion, and there's nothing that an individual or a small group of people can do. I mean, they can only adapt to the changes, and governments are not trying to stop the problem because fossil fuel companies are still making record profits, and as much as renewable energy is growing, the fossil fuel chunk is still there, and the lobbies are strong, and our planet is changing. I mean, our climate is changing, our weather is changing. So we have self-determination within that scenario, but we don't really have individual ability to change it. So the thing is the Arctic, the Arctic, James Bay and Hudson's Bay, like all the Arctic, is warming at incredible rates. There's less and less sea ice. The sea ice is thinner, so it's more mobile. It moves from one location to another location. But those are transition effects. Okay, in a few years, there'll be no sea ice at all for people to worry about. Okay, it'll be completely gone.
Yeah,
and we'll be in a different world. So this is where we're
map, I have one here, and I could share screen.
Well, I'll put it on later, Adele. Don't worry.
But I really need to sort of comment here in that the Arctic is warming quickly. Things are getting worse, as Paul has unfortunately outlined, and therefore, even if we had a methodology to fix what's wrong now and make the ice return, it wouldn't be permanent in any way because it's getting warmer and warmer. And the way things are going, it'll keep on getting warmer. So what will work now to make the ice come back will stop working, before too long at all. So it doesn't seem, really worthwhile to do that. I wonder about the local people. They're continuing to adapt. They're famous for adaptation to circumstances, and I think best to assist them to adapt rather than try to return the ice. And then even if we spend a lot of money on it would stop being useful as when the climate continues to warm.
Well, look, I mean, everybody here is right in some way. For sure, Megan is right. We do not act as if we can go in and do things that as if we run everything. No, and we wouldn't. And that's why we're asking Megan and Lawrence, and we will be inviting other people because we want to consult as we go along and get feedback. And of course, Paul is right. Nobody has control over the world's climate today, and that's the problem. It would be nice if we did, And for Adele, I would say you're right that what we could do probably, if at best, would maybe cool parts of the Arctic or of Hudson Bay for a while. And the question is, can we keep it up long enough and keep it up enough to make the kind of difference that we want? Now, here's the point that I would like to introduce now, which is that probably the cloud brightening is not going to be enough to do the job, but it's possible to combine the cloud brightening technology with one of the other methods that Paul has mentioned, the thinning of the cirrus clouds. That is, if you knock out the ice in the high clouds, then that will actually allow some of the Earth's heat to escape. And as I understand it, you could do that throughout the winter. You could seed the clouds, the cirrus clouds that are very high, and that would allow some of the heat from the planet, and especially, of course, from the Arctic, to escape. The problem there is, one of the problems, and that might even be the problem for the cloud brightening, that you could increase the amount of rainfall in another part of the world. As I understand it, the Sahel in Africa and the monsoons in India and Pakistan might become real floods. And this is the reasons some of the people have said, well, we could do it. We could knock out some of the cirrus clouds, but it would possibly have negative effects on people elsewhere. And so they sort of said, don't do it. We don't know enough yet. So I think that this is the kind of thing we could combine the two approaches, the eliminating, thinning the clouds, the cirrus clouds, along with the cloud brightening. You could do both, and this would multiply the effects of cooling the Arctic. Again, there are some dangers involved. Another approach that Paul hasn't mentioned, and maybe I don't know, one of you should describe, which is that you could take water from underneath and spray it on top of the existing ice. As I understand it, that's how they make ice rinks, keep ice rinks cold, is they go along the top of the ice and spray it so that it keeps thickening the ice. So, Paul, would you explain how that would work? And I know that Stephen had, when I spoke to him last about that, you have some objections to doing that. So the point is, there are downsides or potential dangers in all of these things, and that's what we want to think about, is the problems that we're causing. Paul, explain
why. I'll start off with Ottawa. The canal, this is the first year ever that the Rideau Canal has not frozen sufficiently thick for skating. And this, skating in Ottawa has been going on for many, many years. I don't know, 50 plus years. I don't know how long when the canal was first developed as a skating rink. It's 7.8 kilometers long, touted as the longest rink in the world. And what they do is when ice thickens, of course, ice growth starts off very, very fast, from cold air above. And of course, it freezes on the bottom, and thickens always just on the bottom. So you need the heat going through the ice from the atmosphere to the bottom of the ice to chill the water enough to freeze it onto the bottom. Ice is a good insulator. So the thicker the ice grows, the slower the process occurs. So ice thickening, goes on a curve and slows down. So if you take water from underneath the ice and pump it on top of the ice, you can greatly increase the thickening rate, at least double it, because now the water is freezing on the top of the ice and on the bottom of the ice. So you can get much thicker growth rates, or you can pump, slushy sort of water on top, or people have tried different things to enhance the process. And you, of course, want to get the snow off the ice, because snow is also a good insulator. So if you want the ice to thicken faster and it's got a snow layer on top, you plow all the snow off, right? So that the heat doesn't have to go through the snow and ice, which are both insulators. It just goes through the ice. So, these techniques have been used for years and years to enhance the longevity of ice roads in the far north. So I know, I do some work with some people in Winnipeg, and a lot of the First Nations people, communities east of Winnipeg have no have no road access during the summer, right? Lots of little islands and so on. But in the winter, if it's cold enough, they make these ice roads, which go island hopping basically. And then transport trucks can drive goods across to the communities in the winter. So these ice roads are very important, and they've been doing this for many, many years. But now it's much harder to make these ice roads because of the warming temperatures, and they don't last as long. But if you can get an ice road in operation for even 3 weeks or a month, it's worth your while doing it, because in that time when it's open, you can get huge amounts of goods transported. And if you don't do it that way, you have to fly them in basically, or some could go in by boat perhaps. But anyway, so the technology for thickening ice has been around for a while. So some of those methods, some people have envisioned, little renewable energy sources, say, little wind turbines, running a pump, pumping water from below the ice to above the ice, etc. But of course, the Arctic is vast. I mean, to do it, to think of a concept like that, being effective to thicken the whole ice is just absurd up there. So we're looking at all of these different technologies and ideas. The National Capital Commission in Ottawa has hired a bunch of engineers at Carleton University to try to find ways to thicken the ice on the canal for skating, and also for extending the duration of the skating season. But with warming climate, these things are all kind of band-aids right now. I mean, the climate is warming so quickly that here's a couple things, okay? Right now, the Arctic sea ice is near record lows, extent and area. Antarctica is way, way below record lows, okay? And we've been coming out of it, we're still in a La Nina, where there's not too much heat coming out of the ocean. It's supposed to be a bit cooler than otherwise. When we're heading into an El Nino, and if it's a super El Nino, we're likely to blow past the 1.5 degrees Celsius target in 2024, 2025. If it's a super El Nino, such as, as strong as they say the 1998 El Nino, or the 2015, 2016 El Nino. So those were both super El Ninos, very powerful El Ninos, lots of heat coming out of the ocean, lots of heating of the atmosphere. So the next super El Nino will blow away all temperature records on the planet. And the Arctic will continue to warm even more. And it will only be, who knows exactly when, but we're going to have what I call a blue ocean event in the Arctic, where there's no ice at the end of the summer season, or less than 1 million square kilometers is the number that lots of people use. That ice, I think, will be circulating. The ice that is left, most scientists say it'll be fast ice. It'll be along the edges of the coastlines, et cetera. I think that's complete nonsense, because those regions are much lower latitude. That ice is going to be gone much faster than, say, the last ice that's circulating in the Arctic, I think, will be circulating around the North Pole. I don't understand, there's too much compartmentalization in science. People are all in their own little areas. They don't have enough system thinking. But we're heading to an ice-free Arctic, whether it be in 5 years or 10 years or 15 years, who knows, right? It's hard to make predictions on that, but that's where we're heading. That's where the trend is going. And once that happens, as Meta was saying, the concern is big relief. We know all about the permafrost, the amount of carbon stored in there. When that goes into the atmosphere, CO2, methane, et cetera, we're heading to a much warmer world where there's much less ice and snow in the Arctic. There's no sea ice in the summer, and then or in, say, September. And then within a few years of that, there's no sea ice for August, September, October. And with a few more years, there's no sea ice for July, August, September, October, November. Right. And then eventually year round, I think no sea ice in the Arctic. The only ice up there will be covering Greenland. Now, the way the jet streams the jet streams circle around the center of cold, if you like, which is near the Arctic, near the North Pole right now, but offset towards Greenland, because we've got this, just look at the map and you've got this, where's the center of cold, if you like, the centroid of cold, and it's not in the North Pole, it's centered towards Greenland. But imagine with no sea ice, the only snow and ice is on Greenland. The center of Greenland is about 73 degrees north latitude. So not only will the jet streams slow down and become wavier, causing all these extreme weather events, but the jet stream will rotate over a lower latitude area, so that will offset. So the whole climate system is rewiring and changing, and it's going to affect how we grow food on the planet. It's going to affect every person on the planet. And this is where we're heading. This is what the best overall system science is. Not many people are studying this, but more and more people are becoming on board. It's why I do my videos. It's what I've been doing for years. It's why I have about 1,500 or plus videos on YouTube. I try to educate the public as to what is happening. So we're talking about trying to preserve. What we're talking about is really, think of it in terms of the big picture of things, right? So it's,
okay, thank you, Paul. And I think we don't have much time left. I think I would like Stephen's response to all this, because we've kind of taken your idea and have gone every which direction with it. And you may, what's your response to the diversity of perspectives and concerns that we've introduced here? Do you still feel we're on target with your basic idea?
First of all, I'd like to say something a bit about this ice thickening. Now, that will work very well if you're only wanting to thicken one ice rink or one road. But you're actually putting relatively quite hot water on top of the ice, and you're going to be warming up the air above it. So you'll be thinning ice somewhere else. Okay, it's a small area at the cost of you warming up slightly a much bigger area. Now that means that it's the air above the ice that you're treating is not an infinitely large heat sink. Okay, and if you were to work out if you're going to freeze 1 square meter and put that heat into 1 square meter of air above where you thicken the ice, the temperature of the air is going to go up to about 30 degrees Celsius for a meter thickness of ice and a meter square area. It's the ratio of the relative heat of fusion of the ice and the specific heat of the air above it. And you'll get really hot if you concentrated all that heat into just the area of the ice that you've produced. It's going to be very much hotter. So it's a small area solution. Okay, so are we going to say we kind of ruled that out? And what's left now is a possible combination of the two methods that we've considered. We haven't looked deeply into the cirrus cloud idea, but as far as I know, you could combine the cirrus cloud thinning with the summertime cloud brightening of the low-level clouds, right? Yeah. You could also increase the reflectivity in the high stratosphere, and there are people who are designing ways of doing this from aircraft. The trouble with that is that it's got a much longer life than the cloud brightening. If you did cloud brightening in the winter, it would work in the wrong direction. The cloud brightening has a very short life, and if you stop doing the spraying within the lifetime of the next snow shower, the next rain shower, it's all been forgiven and forgotten. So we would only doing it for about 3 months over midsummer, and then we would stop. And you can't be quite sure that the stratospheric sulfur idea for cooling is going to stop quickly enough. Some people say you can do it quickly, but other people think it goes there for 2 or 3 years.
Okay, so Stephen, the 3 months over midsummer, for cloud brightening, that would only be done over open water. Is that correct? You wouldn't do it over areas, say, of Hudson's Bay that were ice covered.
Well, it would be much less effective if it's already a very good reflector.
Right.
Okay. So that's the only reason for not doing it. But
so you would right. So you would do it over a region. If it worked and the ice formed, you would then move to a different region of open water and do it there and continue on. Is that correct?
The effect is spread over a whole area. So what would happen is where there is a border, the ice will be going more towards the open sea. And you can choose exactly where you do it. If you know what the wind direction and the wind speed is going to be, you have really quite a lot of control over which bit you want to cool. And we would be wanting to do it with from vessels that are very mobile and can go extremely quickly if they're not spraying. So you could go from the North Pole to the South Pole in about 3 or 4 weeks. So we wouldn't be wanting to do it in the winter in the Arctic anyway, because there's no sunlight to reflect. But they would be off to Australia or the Caribbean or whatever you want to do. This is a very, very fast moving vessel when it's not spraying. So you can choose where and when to stop.
That is so, every time I talk to you, I learn more that makes me want to know more about other things, raises questions. I'm going to give the last word to Lawrence, because you actually are in a situation where you can go talk to people and consult and ask people what they want and how they feel about all of this. So is there anything we can do to present more information to you that might be useful?
Well, I think this topic is a good starting point. Automatically the people will say, well, it's one ecosystem. You can't try to affect change in one section without affecting the other. So I think that has to be kept in mind. If you're going to go out talking about this, you have to have answers ready for those kinds of questions. And the thing is also many of the communities I'm working with are inland. So their concern is more on the permafrost melting as opposed to the ice thinning in the Hudson Bay. If they spend more time on the land, on the rivers and so forth, and they see the impacts there. So what can be done would be the question on the permafrost melting as opposed to trying to work on the Hudson Bay ice.
Well, Lawrence, if you
want to ask,
sorry, this is important. If you manage to restore and thicken ice on Hudson's Bay and James Bay, then that will cool temperatures inland and help the permafrost. Certainly, you won't have open water on coastlines because that will causes huge erosion, especially with high wave action, and can degrade coastal permafrost. But if you have an ice layer over the bays, it's going to be much cooler inland because the onshore breezes, for example, are colder. It acts more as a continental climate situation rather than a climate on a shoreline. And if you're next to a lake and the lake is ice covered, you don't have the warm, moderating lake effect occurring as long as there's ice cover on that body of water. So it's a big improvement for cooler temperatures inland. It's not independent of the state of the ice on the bays. Just so
I can see the other thing that people are saying, well, you also have to stop polluting now. There's still a lot of CO2 that's going into the air that's arriving into our territory. So stop that. Maybe you'll have a better chance of doing what we're talking about doing here.
You need both.
Yeah, but I mean, I'm wondering if it would be interesting if we could get some sort of feedback from people that live up in that region. Like, for example, send your friends and people that this video, right, and other videos where we're talking a lot about Hudson's Bay and what's possible, because people aren't aware. They wouldn't be aware that anything was possible at all.
Well, let me mention here an option, because underneath the screen, I'm gonna edit this and post it tonight on our website to savetheworld.ca. And when you scroll down under the screen where you can watch that, there's a place that says public comments. So if you click there, it'll take you to a place where you can comment. And so I want to encourage people, anybody in the world who's interested in this issue, to go there and post your thoughts and issues and questions. And you can, there's also, you can reply to each other. So we can have a real discussion continuing about what we've raised today, because there are 1,000 more things to be said on the subject. And that's the place to do it. Please use it. Feel free. Anybody can go there and post your thoughts or questions and have a continuing conversation about this. So we're not through, but we're through for now. We've used up our time. So I'm very, very grateful to all of you. And I think
I have one burning question for like
right.
one minute.
Sure. Yeah.
Okay, well, I'm wondering if there's any role for seeding the clouds from above. And particularly, there's obviously planes that exist. I'm not, but it instead of from below, from above. And then also, if you could do that from above, you might save the permafrost.
Does anybody know?
You don't need to do it from an airplane. You can do it all from boat ships on the sea, because the air above the sea is very turbulent. It's a bit like putting some cream in your coffee and stirring it. So this little salt fragments that we're getting are going to get up to where the clouds are, whatever happens, because the air is turbulent. So it's much cheaper to release them at the surface than to fly.
All right.
So you don't need
you're generating the cloud condensation nuclei, the little salt crystals that are engineered to be the right size to make the proper types of clouds. The source is seawater, which you're pumping through nozzles. So if you're on a plane, you're talking about huge weight transport. You're talking about a Hercules full of water, seawater, to pump it through the nozzles. Like you have to figure out how to create those little particles. Yeah. So that's, it's much cheaper and easier just to use seawater from the ocean. If you pump it a few meters, a few meters or tens of meters above the surface, air turbulence is going to carry it very quickly and distribute it amongst the boundary layer, which is about the bottom 1.5 kilometers above the surface.
You get a pretty even mixture very quickly. Yeah. You have to think about the size of the fragments that we're putting up. It's a bit like having a marble being dropped in a liquid that's 100 times thicker than syrup. Okay, so you can pretty well forget how fast the little dry fragments would fall if the air was still. The air is moving around randomly with velocities very often a meter per second and more. And this is a way of stirring your coffee cup.
Okay, well, that's the end of our conversation for today. And we will be back in about a month. So watch your timetable, I'll let you know. And we'll have a continuation of this, to me, extremely interesting and maybe important